So thank you so much, Dr. Shakir, for inviting me here today. And it's a pleasure to be here. It's a pleasure to help you guys understand the math section of this very important test that you all will be taking relatively soon. I'm going to be spending about 2 hours or so of time with you today. So please take out your pencil, have some paper in front of you so that this can be a working session. I don't want to just show you the answers. I'd rather you kind of think through it on your own first, and then we can discuss it as a group and see how you guys did. This is your test. I'm here to help you prepare to pass your upcoming test. So Ashley, Camille, Jordan, and Michaela, if you are able to turn your cameras on, please do. Thank you, Jordan, for having your camera on. It's just better that way to be able to interact with you. So if you're in a place where you can turn your camera on so I can see your face, that would be awesome. And let's go ahead and get started. So I'm going to share my screen overview of the math section. So this is let me scroll up to the top. This is the Florida Teacher Certification Exam, FTCE. And so I just scrolled down to where it talks about the math section. So if you scroll down, you'll see that the math section has a on-screen four-function calculator, so basic calculator that's available to you on the screen. And so if you have a calculator with you today, or if you want to just use your cell phone as a calculator today, that's perfectly fine. But on the real test, you will have an on-screen calculator provided to you. And then you see that the math section is broken down to 4 different competencies. So competency number 1 is your knowledge of number sense, concepts, and operations. And that's approximately 17% of the questions. Competency number 2 is knowledge of geometry and measurement. And that's 21% of the questions. Competency number 3, that's your knowledge of algebraic thinking and coordinate plane. That's 29% of the section. And then lastly, competency number 4 is your knowledge of probability, statistics, and data interpretation. And that's 33% of the questions. So what I figured we would do today is, and it breaks it down into more in-depth competencies if you scroll down the page. And so this is the public website. You can go to this website and pull it up for yourself. But what I figured we would do today is do some practice questions that are posted on this website. As I said before, I know some of you just joined in. So if you can please turn your cameras on, take out a piece of paper, get a pencil or a pen, get a calculator, whether it be a calculator from your phone or from your computer or a handheld calculator, so you can do some calculations. That way you're actually working through the problems, and then we can work through them together and we can see how you guys did. Okay, so anybody have any questions about this math section before we get into some simple questions? Okay, I don't see any. If you do, just feel free to unmute yourself and just speak up if you have any questions. If not, we'll go ahead. I'm going to jump to section number 7, which is some math multiple choice questions. And we're going to begin some sample questions. And you see on this page before we begin, it says the test format and simple questions. So you'll have approximately 40 multiple choice questions, and you have 100 minutes to complete the 40 questions. So your first math question is, if you have 100 minutes and you have 40 questions, how many minutes per question do you have on average? Who can tell me the answers to that? How many minutes per question?
About 2 minutes.
2.5.
2.5.
2.5 minutes.
2.5. So if you have your calculator, I have my phone. If you have your calculator and you divide 100 by 40, you'll get 2.5. So you have about 2.5, that's an average. That means that some questions will take you longer to answer and some will take you shorter to answer. So on average, you have 2.5 minutes. So when you're practicing for the math section, it's important that you keep in mind the time constraint. So for the purpose of today, I'll give you 2.5 minutes to try the problem on your own, and then we will discuss it as a group, okay? And then you'll see at the bottom here the types of questions. So you have scenario questions where you have to examine a situation, a problem, or a case study, then answer a question, make a diagnosis, or recommend a course of action by selecting the best response. You have word problems where you have to apply mathematical principles to solve a real world problem. You have direct questions where you choose a response option that best answers the question. You have command questions where you select the best response option. You have graphics where you choose the option that best answers a question involving a number line, a geometric figure, a graph of lines or curves, a table, or a chart. So those are the types of questions within this 40 multiple choice questions, 100 minutes long, consisting of 5 different types of questions. Okay, so now we're ready to begin and go through some sample questions. So here's question number 1. I will leave it on the screen. Again, I'll give you 2.5 minutes. It may not take you that long, but that's the time you have on average. So I'm going to start my timer. 2.5 minutes. Try it out. And when you're done with the question, if you can give me a thumbs up, that will let me know when everybody is done. So Rashawn is done. You have about 30 seconds left. Jasmine, I see your thumbs up. Jordan, thumbs up. Ashley, Camille, Crystal, Michaela, give me a thumbs up when you are done. All right, so that's our time. So, Jordan, what did you get?
C.
C greater than. So when you, how did you go about solving this problem, Jordan?
First I changed them to decimals, and then I knew negative 0.33 was greater than negative 0.40. So
Awesome. So we can check C and move on to the next question. Okay, so here's the next question. This is competency number 1, knowledge of number sense, concepts, and operations. I will give you 2.5 minutes to give it a try. Starting now. Jordan, I saw your thumbs up. Again, remember to give me a thumbs up when you're done. Camille, I see yours. Rashawn, I see yours. You have 30 seconds left. Okay, that's 2.5 minutes. So let's see, Rashawn, what did you get for this one? And you're on mute.
I said I got 8.
8? 1320?
Yeah.
Okay, so tell me what your process was.
So like I wrote all of the numbers down, and then I read the question, and the 40% went to the printer. So I changed the 40% to a decimal. So I multiplied 0.4 times 300, and that gave me 120, which is 40% of 300. And then I added it to the 1200, and that's how I got 1320.
So here's a question. I want you to read that second sentence where it says an electronics store has a promotion. Read that sentence. Read it so we can hear you.
An electronics store has a promotion that offers a 40% discount on the printer.
Okay, so when it says a 40% discount, does that mean, what does that mean?
Oh, I see where I went wrong. I was supposed to subtract the 120 from the 300, right?
Right, because that's what we're saving. We're saving 120. That's our discount. So we're saving 120. So we're spending 180. Right? So we're spending 60%, we're saving 40%. So instead of doing 300 times 0.4, you do 300 times 0.6. Because 0.6 is what you're spending, 0.4 is what you're saving. Does that make sense, Rashawn?
Yes.
Okay, good. So now if we do that, the printer cost is just going to be 180 with the 40% discount. Spending 60%, we're spending $180 from the printer, and we're spending $1,200 for the computer. So altogether, it's what?
The 1380, right?
1380. So that's a good example just to show you that the wording of the questions you got to read it very carefully because it's so easy to make a simple mistake. And you notice that the simple mistake answer is going to be there for people that don't read it carefully. But we caught it in time, so we're going to choose 1380. Now we're ready for the next question. All right, question number 3. Which of the following symbols should be placed in a box to form a true statement? So I'm going to give you just 1 minute for this. I think this shouldn't take you 2.5 minutes. So take about a minute for this one. Okay. Jasmine, what did you get for this one?
I put C.
C, greater than. Okay, I think we can all agree that if you have 3.4, that's bigger than 3.3. 09 or 09. So we'll go with C. Move on to number 4. Students in a mathematics class are allowed to drop their lowest quiz grade. If a student earns the following grades, which grade will be dropped? Okay, which one should be dropped? You got 2.5 minutes for this.
Jasmine had her hand up still.
Oh, Jasmine, did I miss you?
Oh, my bad. I just tried to put my thumbs up.
Oh, okay. You're done. Okay.
Yeah.
I see your thumbs up, Sean. Jordan, I see yours too. Perfect. Okay. So let's see, Jordan, what did you get for this one?
I got D.
D. And so how did you go about solving it?
First, I converted all the fractions to decimals, then found the smallest number from there.
Perfect. So 6/10 is 0.6. So I guess we can click and see the answer. So we're right. So D is correct. Okay, next one. Question 5. An electronics store has a current inventory of 50 stereo systems. The lowest price stereo system in the store sells for $800, and the highest price stereo system sells for $3,000. Which of the following is the maximum amount of 3,000 systems on hand if the current inventory totals $111,000? You have 2.5 minutes to give it a try. Let me just, oh, okay. Okay, Rashawn, I see that in the chat. And yes, you will be able to get the recording. Okay, let me share my screen again. Okay. Let's see. Jasmine, what did you get for this one?
I didn't know how to do it.
Okay, so explain to me just the setup. I know we just read the questions together. Explain to me the setup.
I put I wrote down the lowest price. Well, first I did the 50 stereo systems, and then I wrote down the lowest price, and then I did the lowest price for 800, and then I put the highest price for 3,000, and then I didn't know what to do after.
Okay, what about you, Rashawn? I know you have to go soon, but did you have any ideas on this one?
I just used the answers and like, hold on, let me make sure I'm reading this correctly. But yeah, I just multiplied the 3,000 by like pretty much each of the answers until I got the one that gave me 1,100. I mean 111,000.
So what did you get?
I got D.
So D will be right if there were no other stereo systems, right? Because D will be the answer if they were all $3,000. You would have 37 $3,000 stereo systems for a total of 111,000. So that would be the answer if every last stereo system in the store was the same price. But it tells us that the lowest price stereo system is $800 and the highest price is $3,000. And there's 50 in total. So I think we can eliminate D actually, because that would mean that there's no other stereo systems. They're all the expensive kind, the expensive brand. Does that make sense, Rashawn?
Yeah.
Yeah, so we can't choose D for that reason. But I love your method though. I love your method of using the answer choices and seeing which one works. So what happens when you choose C? Because C is the next largest. So what happens if you have 35 $3,000 systems on hand? How much would that cost?
I think it was like 102,000 when I was doing it.
We'll go ahead and do the math. If you had 35 of the $3,000 systems, that will cost how much in total?
It was 105,000.
105,000. And that leaves how much money for the other systems?
6,000.
6,000. And how many others? So that's 35, which means how many stereo systems do you have left?
15.
Right, 15. Okay, and then what's 15 times the 800, which is the lowest?
$12,000.
12,000. So you see how that doesn't work, because if you have 15 systems left over and the lowest is $800, that's 12,000. That is too high because we only have 6,000 remaining. Does that make sense?
Yes.
So 35 is too high. That's too high for the number of $3,000 systems, because that means 15 left over and that number doesn't work out. So let's now try choice B. Let's say you had 32 of the $3,000 systems. So how much money is that? 32 times 3,000 is what?
It gave me 96,000.
96,000. Okay, so we had 32 of them. So how many systems do we have left?
$18.
18. And let's say those 18 are, and how much money do we have left? If we have $100,000 in inventory and we take away the 96,000, how much money do we have left?
15,000.
15,000, right. So let's say those 18 were all at the minimum, $800. Is that amount bigger than, greater than or less than 15,000?
Can you say that one more time?
Yeah, so the 18 systems we have left over at $800 per system, how much money is that? And is that is less, right? 14,400. We have 15,000 left in inventory. So that number is less, the 14,400. So that means that's possible. It's possible to have the 32 expensive systems and to have 18 of the least expensive systems, because that inventory is under the 111,000. Then we can have the leftover be for another system, a third type of system. Does that make sense?
Yes.
Okay, so what we did is we noticed that 37 of the $3,000 systems was too big, because that equaled exactly 111,000. And that means that we wouldn't have any other type of system. So it can't be D. Then we went up to C because we're trying to find the maximum number of $3,000 systems. So I said, okay, what if our maximum was 35? We did the math on that. We got 105,000, which means there's only $6,000 left, but we have another 15 systems left. So that didn't work because our 15 systems cost us more than 6,000. So then we crossed off C and went up to 32, which is the next largest, the next biggest on our list. And with 32 of the $3,000 systems, that gave us $96,000. We have $15,000 left, and we come in under that with the remaining 18 systems. So that one should be the maximum number of the $3,000 systems we can have. And let's check. And yeah, it's B. Okay, does everybody understand that? Jasmine, do you understand that now?
Yes.
Okay, what about you, Jordan?
Yes, ma'am.
Okay. All right, so let's move on to question number 6. And you see the question on the screen. And go ahead and take, I'll give you 2 minutes for this one.
Rashawn, did you have a question?
Yeah. Are you gonna be sending the recording of this like through email?
That'll be a decision made by Mrs. Miles. Remember, we're recording in her class.
Okay.
So we'll discuss how that will be distributed to you.
Okay.
Uh-huh. Do y'all know who sixed this? Hold on, I'm gonna start. I'm recording again now.
Okay. All right, so you guys take a minute or so left for this one. Okay. Jordan, what did you get for this one?
I was still working on it. I was a little confused.
A little confused?
Yeah.
Okay. Beatrice, did you have a chance to try it?
Not yet. I'm going to try.
What about you, Jasmine?
I was almost done.
Okay. I'll give you a few more minutes. I'm going to stop sharing and go to my whiteboard so I can
I was just writing the question because I entered late.
oh wait. Dr. Shakir, is there a whiteboard feature?
Yes, we do have a what. I'm gonna stop recording just for 1
All right,
second.
see, okay. So let me let's work through this one on the whiteboard. I think it's easier to see. And I'll write the question down. Okay, so the question says 15 minus 3 divided by, one second. 15 minus 3 divided by 2 plus 1 times 8 minus 6. So the key thing here is that you do order of operations. So we do what's inside the parentheses first. So Jordan, what's 15 minus 3?
12.
12 divided by, what is 2 plus 1?
That's a plus. I put a division sign when I was doing it. I'm sorry. 3.
3. And then times, and then what's 8 minus 6?
4.
8 minus 6?
5. 6. I'm sorry. Wait, 2. 2.
Okay. All right, so now that we've done the parentheses, now we can do order of operations, which says, you know, we can do division, multiplication in any order. So what is 12 divided by 3?
4.
4 times 2?
Which is 8.
8. Okay, so let me go back to the other screen. And we're going to choose C, which is 8.
Okay.
And
I thought that was 2 divided by 1. That's 2 plus 1.
yeah, sorry, I can blow it up a little bit. Is that easier to see?
Yeah, that's a little bit.
Okay. All right. So order of operations, remember you do parentheses first, and then you do your multiplication division. And then if you have at the end any addition, subtraction, do that at the end. But always start with parentheses and then exponents, PEMDAS, and then division, multiplication, and finally addition, subtraction. So let's move on to the next one. All right, question 7. A building 51 feet tall casts a shadow 48 feet long. Simultaneously, a nearby statue casts a shadow of 16 feet. How tall is the statue? Take a few minutes, try it out. Okay, Jordan, I see your thumbs up. All right, Jordan, what did you get for this one?
A.
Okay, you got 17 feet. And how did you get 17 feet?
Okay. So I set up proportions. So I put for the first one, 51 feet is equal to 48. Well, 51 feet over X equal to 48 over 16. And I just lined up the,
Right. So you said the building, which is 51 feet tall, has a shadow that is 48 feet long. And then you want to know how tall is this other building that has a shadow that's 16 feet. So you set up your proportion in this way. So 51 feet for the building, 48 feet for the shadow, X feet for the building, 16 feet for the shadow. And then we can just do a cross multiply and solve. So when we cross multiply and solve, we do 51 times 16 equals 48 times X. So 51 times 16 equals 48X. And then on your calculator, you can do all the multiplication and division. So 51 times 16 is 816 equals 48 times X. So divide by 48. And you'll get that the building is 816 divided by 48, which is 17. And this was in feet. So setting up a proportion for this one gives us 17. So then we go back to the question here and we choose A.
I had a question. Do you
Yeah.
know, like an estimate how many these type of questions are on the test, the GK?
These type meaning proportions?
Yeah, the proportion questions type questions.
Well, that's something that we can keep track of. So we've seen one so far, right? This one. And as we keep going through other questions, we'll see if another one comes up. So if we go back to the other screen, it told us, do you remember how many total questions there were?
No, ma'am.
Okay, so let me go back to section 3 where it had the review of the section. So here was the different question types. So that was what I would call algebraic thinking. So it says 29% of the questions. And if we go back, we know there's 40 total questions. So I'm gonna guess and say there could be 1 or 2 proportion questions, but there's no way of knowing. But you know, there's 40 total questions, and you have different types of questions and different competencies. So, you know, we can't really say for sure, but you can safely say there's going to be 1, maybe 2.
Okay, got you.
Okay, so we put 17 for that one. So, all right. There's 40 questions total. This question bank has 45 questions, so it has 5 more questions. But we'll see if there's another proportion question that comes up in the course of the 45 questions. All right, so next one, question 8. A rectangular animal pen will be built using 200 meters of fencing. If one side of the rectangle is 60 meters, find the area of the pen. Okay, take a few minutes and work through that one. Okay, Jordan, I see your thumbs up. Beatrice, Jasmine, give me a thumbs up when you have an answer.
Okay.
All right, Beatrice, I see your hand up. Is that a question or that means you're finished?
I'll finish.
Okay. All right. Awesome. So, Beatrice, what did you get for this problem?
A.
You got A.
Mhm.
So, walk us through how you solved it.
Mm,
So I'm going to go to the other, my whiteboard, so I can write it down. Okay, so it says we have a rectangle animal pen, so we can draw a rectangle. That should be our first step, is to actually draw a rectangle. And it says that we built using 200 meters of fencing. So in total, we have 200 meters of fencing. And one side of the rectangle is 60 meters. So one side, it can pick any side we want. This is 60 meters. And it says find the area of the pen. So, Beatrice, how do we find the area of this pen? What was your first step?
I just guessed the answer.
Yes. Okay, so if this side of the rectangle is 60 meters, what is the side right across from it?
60.
Also 60 meters, right?
Mhm.
And this is how much fencing we used in total. So
Yes.
we add up all four sides, because remember, all four sides have fencing, and we know these two sides are the same.
Yeah.
Then we can write an equation. 60 plus 60 plus x should equal 200 meters of fencing, right?
Yeah.
So 2x plus 60 is 120, should equal 200 meters of fencing. So how do we solve this?
So we take 2x is equal to 200 minus 120.
Right, so what is 200 minus 120?
Mm,
And remember, you can use a
80.
What is it?
80. 80.
And then we divide by 2.
Yeah. That's
So
40.
okay, so now we know both of these sides are 40. So the area of a rectangle is length times width.
With, yeah.
So 60
Plus
times 40
40.
is what?
120.
Is what?
100. Hey, sorry. Okay.
What is it?
2,400.
So that is the area of that pen, 2,400, which means, to go back, our answer choice is C, 2,400. Okay, so Beatrice, it's really important for you to draw a diagram when necessary and to label your diagram to help you figure out, how to approach the question, especially in geometry. It's really hard to do a geometry question without an actual diagram. Because they don't give you a diagram, you got to draw one for yourself. Okay. All right, Jasmine, you good with that? Okay, let's move on to number 9. Which of the following geometric figures must have perpendicular diagonals? So this is really a question of what you know about these 4 different shapes. Which one must have perpendicular diagonals? And so just like I said in the last question, it may be helpful for you to draw these 4 diagrams and help you figure out which one has perpendicular diagonals. So go ahead and draw it out for yourself. Draw a quadrilateral. A quadrilateral is any 4-sided shape. Quad means 4. So quadrilateral could be a square, could be a rectangle, could be a parallelogram, could be a rhombus, could be any of these. A parallelogram, do you guys know what that looks like? Don't remember? Okay, let me go to my other screen. I'll show you my whiteboard. Okay, so quadrilateral literally means any 4-sided polygon. So a quadrilateral could be a square, could be a rectangle, could be a kite or a diamond, anything that's 4-sided, and that's the closed figure is a quadrilateral. The parallelogram, both sides are parallel and equal in length and at a slant. So this will be a parallelogram where these 2 sides are parallel and then these 2 sides are parallel. Okay, and then another choice was a rectangle. So for a rectangle, you know that all 4 angles are right angles. And that you know that the opposite sides are congruent and parallel. And a rhombus is almost like a square, except for the sides are slanted, but they're all equal in length. Okay, so if you were to draw, so we know it's not going to be quadrilateral because that's a category of shapes. That's not specific enough. So if you look at the parallelogram, the rectangle, and the rhombus, if you were to draw the diagonals, right? Diagonals are from corner to the opposite corner. Here's diagonal, here's the diagonals, and here are the diagonals. Which one of these, and you may want to draw your parallelogram a little bit different from mine, so it's like a little bigger. Well, so that it's, let me erase that, so that the sides are not the same. Otherwise, it looks like a rhombus. So it may be better to draw like a long side and then a short side. So it looks a little bit different from a rhombus. The way I drew it, it looks almost like a rhombus there. So that way you can see the diagonals a little bit better. So of these shapes, which one would you say has perpendicular? What does perpendicular mean? Anybody know?
Is it they cross at a 90-degree angle?
Exactly.
Wait,
So
yeah.
you want to know, do these diagonals cross at 90-degree angle? Do these cross at 90-degree angle? Do these cross at 90-degree angle? Or this is the same as this parallelogram, this or the rhombus, do these diagonals cross at 90-degree angle? So based on your own diagram, which one would you say has diagonals that are perpendicular?
The rectangle.
Jordan says the rectangle. No, it's the rhombus. So this is when it's a good idea to kind of brush up on your geometric shapes. If you, I'm gonna just, for a second, I'm gonna just go to a different tab and I'm gonna Google rhombus because it's important to brush up on the characteristics of the rhombus. So you notice the definition of the rhombus is a parallelogram with opposite equal acute angles, opposite equal obtuse angles, and 4 equal sides. Any parallelogram with equal sides, including a square. And let's see, what does a rhombus look like? There's YouTube videos, properties of a rhombus. That's probably something that would be worthwhile to watch to show you the properties. We can go to images, and it shows you images of a rhombus. So if you look at the rhombus here in this image, you can clearly see that these two diagonals make a perpendicular. So it's kind of hard to see when you're drawing it by hand, but it's easier to see when these lines, when the sides are exactly equal to each other. And let's see, there could be some other really good. Let's see what this is. Rhombus. Oh, it says, in addition, a rhombus has these special properties: 4 congruent sides, diagonals are perpendicular bisectors, and their diagonals are angle bisectors. So those are additional properties of a rhombus. They have all the properties of a parallelogram. They have 2 sets of opposite parallel sides. Opposite angles are congruent. Consecutive angles sum to 180. All right, so it's important that you kind of on your study sheet that you write down just to review the properties of a rhombus, review the properties of a parallelogram, review the properties of a rectangle. All right, let's move on to the next question. Number 10. So here's another question that's going to test your knowledge about those different shapes. Select the geometric figure that possesses all the following characteristics. It's a quadrilateral. So quadrilateral, we said, is a 4-sided shape. So we know that we can eliminate triangle, because triangle has 3 sides, not 4 sides. Diagonals bisect each other. Bisect means to cut in half, and has at least one right angle. At least one right angle. So which of these 4 meets all 3 criteria? You guys know what a trapezoid is? I can Google that for you just to show you an accurate picture. Trapezoid. So here's your trapezoid. So the key thing about a trapezoid is that the top and the bottom are parallel. So notice A and B are parallel, and then C and D are, it can be completely up, can form a right angle with the base. A and B are called bases, and C and D are the sides. So notice if you look at this particular trapezoid, there is no right angle. There's no right, it could be a right angle if C, instead of going slanted, if it went straight down, it will have a right angle. But the way it's drawn right here, it does not have a right angle. So we know that the answer cannot be trapezoid because it said at least one right angle. It doesn't have to have one right angle. So it's not that. Okay, so we know it's not triangle, it's not trapezoid. Is it a rectangle or a rhombus? Does a rhombus have one right angle?
It's a rectangle, right?
Rectangle, yes. A rhombus does not have one right angle. Okay, so we gotta know the properties of these shapes. You have to review the properties of these shapes. So when you see a question like this on your real test, you don't get tripped up by it. All right, moving right along. Number 11. Which of the following best describes the faces for the following figure? So we look at this diagram. This triangle here on the front has a 45, 45, and 90. So is that considered equilateral? Is that considered isosceles? What do y'all think? Is this triangle equilateral or is it isosceles?
Is it isosceles?
Yes, equilateral means all the angles are equal, but they're not all equal. So it's isosceles, which means two of the angles are equal, but the third angle is something else. So in this case, it'd be a 45, 45, 90, because we know all the angles add up to 180. So we can eliminate A and B, because it's two, and the second isosceles will be the one on the other side. If you turn the shape around, you'll have another isosceles on the back side of this shape. Okay, so now you have to figure out, is it one square and two rectangles, or is it two rectangles and one square? Sorry, is it one square, two rectangles, or two squares and one rectangle? So which one do you think it is, Jasmine?
I think it's D.
You think it's D?
Yeah.
Beatrice, what do you think?
D.
Jordan, what do you think?
C.
Jordan says C. Okay, so one square, two rectangles. So what we see facing us is this a square or rectangle? This C by A, is this a square or rectangle, Jasmine?
Rectangle.
A rectangle.
Rectangle, right? So now behind it, on the back end of it, is a B by what? We see this goes down B, it goes across the same A. So that's also a what?
Say it again.
Okay, so we know this the front face that we can see here is C by A, so that's a rectangle. So that's one rectangle. Now the back, we cannot see the back, but if we look at the back, it has this B here, and then it goes over the same A here. So it's a B by A in the back of this shape. And then the bottom of the shape is an A by A. The bottom is a rectangle, is a square. It's an A by A square. But this side is a C by A rectangle, and the back of it is a B by A rectangle. So it's two rectangles and just one square. The only square is at the bottom of it. That's the A by A. That's the square. But the other two, the one we can see facing us is C by A, that's a rectangle. And the one that we cannot see, the back of the shape, is a B by A, which is a rectangle as well. So it should be C. Well, it says D. Huh. Well, I don't agree with that. That may be a typo unless I'm seeing things wrong, but this looks like this is a B, and then it runs over the same A. So I think I wonder if this is a typo. B goes down B, and the across is A. So I don't know. I disagree, but somebody can prove me wrong. Okay, next one. Which of the following is the best estimate for the height of a kitchen refrigerator? So this is just an estimate. This is testing you on if you know what a millimeter is, a centimeter, a meter, or a kilometer. So if you think about your refrigerator in your home, is it 2 millimeters tall? Is it 2 centimeters tall? Is it 2 meters tall? Or is it 2 kilometers tall? What do you all think?
I think I'm going to go with C.
Yeah. We know a millimeter is like the size of your fingernail, right? Centimeter is maybe the size of your finger. So that's definitely too small. Kilometers, you know, every kilometer has 1,000 meters. So that's 2,000 meters. So that's too big. So yeah, we could say 2 meters would be a pretty good estimate for the height of your kitchen refrigerator. All right, number 13, which is the best estimate for the height of a mountain? A mountain, of course, is even taller than a refrigerator. So we know it's not going to be centimeters or millimeters.
4 kilometers, C.
Yeah. See. Okay, good. How many square yards of carpet are needed to completely cover a rectangular floor that measures 15 by 19? So draw your rectangle and label the length 15 feet and the width 9 feet. Now remember, this is asking for square yards, and this is given to you in feet. So you have to do a conversion there. Do you guys know the conversion? What's the conversion between feet and yards? Anybody know? Here's a nice reference sheet they give you on the test, and they give you a bunch of conversions. Look at that. So conversion between feet and yard is right here. So 1 yard has 3 feet. This is given to you on the test, so you can refer back to this formula sheet if you don't know the conversion. So 1 yard is 3 feet. So knowing that information, 1 yard is 3 feet, you can come back to this problem and you can convert this over to yards first. Then you can find the area in yards, not in feet. All right, so take a minute or so and do that. Okay, Jasmine, I see your thumbs up. Great, I see yours, Jordan. Jasmine, what did you get for this one?
I got 15 yards.
15 square yards?
Yeah.
Good. So you converted 15 feet into how many yards?
I did 5 yards and then 3 yards, and I times it together.
Wonderful. Correct. All right, we can move on to number 15. A 3-foot wide wood deck will be built around a rectangular shaped pool that measures 15 feet by 30 feet. So you're going to build the deck around the pool. And the resulting shape is also rectangular. If the lumber costs $10 per square yard, what is the cost of the wood for the deck? All right, so take a few minutes, make sure you draw a diagram of this to help you visualize. So draw the pool, label the pool 15 feet by 30 feet, and then you have a 3-foot wide deck that goes around the pool. So draw that around the pool and then try to figure out how much it costs to build the deck. Great, take a few minutes. All right. Jordan, what'd you get?
I didn't get nothing yet. I don't know how to do this one.
Okay, Beatrice or Jasmine? You got, okay. So let me go to my whiteboard. I think the key to this problem is definitely drawing it out. So let me clear this. And so we got a pool. And remember, we also have to do a unit conversion here. So that tells the pool is 36 feet by, no, sorry, not 36. I think it's 15 by 30. So 15 by 30. And this is in feet. But they want the answer in yards. So we have to do our conversion. So 15 feet is how many yards, Jordan?
5 yards.
5 yards. So we can label this side 5 yards. And 30 feet is how many yards?
10 yards.
10 yards. So this is 10 yards. So that's the first thing, is make sure that you convert from feet to yards. And then it says we're going to build a deck. And so if we build this deck around the pool, and the deck is 3 feet wide. So how many yards wide is that?
1 yard.
So this is 1 yard. This is 1 yard. This is 1 yard. And this is 1 yard, which means if the length of this pool is 10 yards and we're adding a yard, so this from here to here is 10, but we're adding a yard here. This is 10, adding a yard here. How many total yards is the deck?
That should be 12.
It's 12 yards.
Mhm.
12 yards long. And then same thing, if this is 5 yards, from here to here is 5 yards, and we're adding a yard here, that was 5, we're adding a yard here. How many yards wide is the deck?
7.
7 yards. So in total, area of the pool is length times width. So it's 10 times 5. So it's 50 square yards, right?
Mhm.
What's the area of the deck? So to find the area of the deck, what's the area? So the area of the pool is the small, this is the pool, it's the small rectangle in here. The big rectangle is this outer rectangle. So what's the area of the pool plus the deck? That's length times width as well. So the length was, we said is 12, and the width we said is 7. So what's 12 times 7?
84.
84 square yards. So now the area of just the deck will be the area of the deck and the pool, which is 84, minus area of the pool, which is 50. So area of just the deck, just the wooden deck going around, is what? What is that?
34 yards.
34 yards, square yards. Okay, so is everybody with me so far? Any questions about that? Because if not, I can go back to the question. So we know that our deck is 34 square yards. So let's go back to the question, which is asking you for how much it's going to cost to build a deck. So if it's 34 square yards and the lumber costs $10 a square yard, Then we do 34 times 10. So how much is that gonna cost?
340.
340. 340. Okay, questions about that? Okay, so that picture was very critical, drawing that diagram and drawing the deck and calculating the area of the pool by itself and the area of the pool plus the deck, subtracting to get the area of just the deck. That's the key, to find the area of the deck and then times it by the dollar amount per square yard. Okay, moving right along, number 16. A teacher covered the exterior of a rectangular prism-shaped box. So imagine like a shoebox that measured 8 inches by 9 inches by 10 inches using one sheet of rectangular shaped wrapping paper. The wrapping paper measured 2 feet by 3 feet. There were no gaps and no overlapping paper. How many square inches of wrapping paper were left over? So you got to do some more conversions here because we have the box in inches and we have the wrapping paper in feet. Okay, so take a few minutes and try it out.
Thanks for attending, Jasmine. I saw your message. So Ms. Miles will have this recording.
Okay, thank you. Have a nice day.
You too. Thanks for your participation.
Okay, Beatrice, Jordan, how you guys feel about this one?
Oh, this one was easy. It was good.
What'd you get?
I got A, 144.
Okay, Beatrice, what did you get? You're on, you are, sorry.
I was thinking of A as well, but I'm not so sure.
Okay, Jordan, how did you, let me see if I can do something. Jordan, if I share my whiteboard, can you show us what you did? I think I have to,
I think I gotta give, let me see. Let
yeah,
me,
I think maybe he has to be a, or
yeah, let me make you a co-host, Jordan, briefly. And then see if you now can annotate on the screen. If you go where the little toolbar is, you should see something there that allows you to annotate. Are you able to do it now? So, okay, I'm gonna show, let me stop recording for a second. Well, we'll just go, it's fine. Okay, so you know, like at the top where it has options, where you can change your window, scroll down, is probably about 8 down, and you'll see something that says annotate.
Okay.
Yeah, and click on that, and that will allow you to annotate. Annotate just means to write and edit. There you go. Come on, my guy, you got it.
I forgot the problem.
okay, I'll read it to you. So it says that a teacher covered the exterior of a rectangular prism-shaped box that measured 8 inches by 9 inches by 10 inches using one sheet of rectangular shaped wrapping paper that measured 2 feet by 3 feet.
Okay. Oh yeah, first I found the area for the prism. So
show me, can you show me? There you go.
yeah. So I multiplied 8 times, what was it, 9 times 10? Well, I can't. Sorry. Yeah.
And that's in inches.
Yeah, those were in inches. I got that. And that was, what was that? Oh, that was 720 inches. I'm sorry, I hate drawing on computers. Okay, and then I found the area.
So that 720 is in inches cubed, right?
Okay, yeah, inches cubed.
So that's a volume.
Okay. Yeah, inches
so that's not an area, that's a volume. A volume is what goes inside, how much you can fill inside the box. We're not filling the inside the box. We're covering the box with wrapping paper, the outside of the box.
Okay. And then I found the area for the other one that was, I converted it first. So 2 feet, then 3 feet, 24 inches into 36 inches. I did that.
So you converted 2 feet into 24 inches and 3 feet into 36 inches.
Yeah. I don't know if you want me to put these right here, but. Okay, and for that I got 864 inches cubed. I mean squared.
Okay, so that's an area.
Oh, okay, so I don't have to put the.
So the 720 is a volume. That's not inches squared, it's inches cubed.
Oh, okay.
And the second number is an area. The first number is a volume, though.
Okay, so is this not correct, the 720?
Well, it's correct in terms of the volume, but remember your objective here is to, how many square inches of wrapping paper were left over? So you have this many square inches of wrapping paper, and you need to wrap this box. Okay, so when you wrap a box, think about wrapping a Christmas gift, right? We have, so think about the sides of the box. We have 3 different sides. We have one side that's the 8 inches by 10 inches. We actually have 2 sides with the top and the bottom. We have another side that's the 8 inches by 9 inches. Right? And then we have a third side that's the 9 inches by 10 inches. Right? These are 3 sides or 3 faces of this rectangular box, right?
Mhm.
So the top and bottom will be the 8 by 10. And then we have, because we have this three-dimensional, let me see if I can draw this three-dimension box. This is what it looks like. So it's like it's 8 by 9 by 10. So we have the 8 by 9 over here. So the front and the back are 8 by 9. So that's here. This is the front and back. Then we have the top and the bottom, which are the 8 by 10s. So in here and at the bottom, 8 by 10s, this is like the top and the bottom. And then we have the 9 by 10, that's the sides, right? So we can say sides. So 8 by 10, 8 by 9, and 9 by 10. So what's the area for each of these?
Okay. So 80 for this one. 72 for this one. And then 90 for this one.
Beatrice, are you with us? Okay. So we have successfully covered those three sides. Remember, there's two of each. This has a top and the bottom. So all of these have to be multiplied by 2 to get to get all 6 sides. So this is by 2, this is by 2, and this is by 2. So when you do that, Jordan, what do you get?
Okay. And 180.
Okay. And then when you add them all up, how much total wrapping paper did we use?
484.
484?
Mhm.
Okay, and remember we had 864 to begin with. So how much wrapping paper is left over?
So we subtract that from 44?
Subtract that from the 484.
380.
All right, so let's go back to the question. And we choose 380. 380 was how much paper was left over. So we had to find, Jordan, we had to find the surface area, not the volume, but the surface area of the box. And then we subtracted the total amount of wrapping paper by the total surface area to get how much was left over. And the correct response is 380. Okay. All right, next one. A building contractor needs to complete the volume. So now we're looking at volume, which is 3 dimensions, of air contained in a building with a rectangular floor as shown in this figure below. The building is 12 feet long. So, I'm sorry, 20 feet long. So we see 20 feet long, 4 yards wide. So we got some unit differences here, 4 yards, not feet. And then 9.5 feet high on 2 sides and 15 feet high from the floor to the peak. So 15 feet high from the floor to the peak. What is the volume of air in the building in cubic feet? So we got an issue here with the yards. We got to do a conversion here with the yards. So we want our final answer in cubic feet. Okay. So think about this shape as it as two different shapes. The bottom, if you were to cut it in half, you have a rectangular prism at the top, and you have a you have a triangular prism at the top and a rectangular prism at the bottom. And if you go back to this study guide here, let me see. They give you what equations? They give you equations for area, surface area, volume. So here's the volume of a prism. Base times height. So you may want to refer to, if you don't know the equation for volume, you can refer to this section on this general knowledge, the mathematics reference sheet that's given to you on the test. Okay, so let me go back to the question. Take a few minutes and see if you can calculate the volume of this diagram, which tells you the volume of the air of the building in cubic feet. Give me a thumbs up when you have an answer for this one.
Yeah, I need a step-by-step for this one. I'm not sure.
Okay.
So
So remember I said treat it like two different shapes. Treat it like a rectangular prism and a triangular prism. So if you were to kind of cut it in half, take the triangle, like take the roof off, right? Then you would have the bottom half would be like a rectangular prism, a rectangular box, right? And the top is like the roof of it is the triangle part, right? If you treat it as two different shapes, you can find the volume of the two individually and add them together to get the total. So let's look at the rectangular part first, Jordan and Beatrice. So the rectangular part first. So you're taking off the roof and just looking at the rest of the house. What's your, how do you find the volume of that?
The volume for the prism?
Yeah, so let me go to my whiteboard again. Okay, so the rectangular part, and then we have the roof, you know, sitting on top of this, but this is just the rectangular part. The rectangular part was 20 feet by 9.5 feet by 4 yards. So we got to convert 4 yards. How many feet is in 4 yards?
12 feet.
Right. Okay, so the volume of this rectangular prism is length times width times height. So we have all those dimensions. We have length, width, and height. So what's going to be the volume here?
$2,280 feet.
2,280 feet. Okay. And that's feet cubed, 2,280 feet cubed. Now, we now have to calculate the roof part, which is this rectangular, which is this triangular. I'm not the best at drawing this, but it's like this. Right? And we know that this is the same 4 yards or 12 feet. And then the length is the same 20 feet. Now this height here is, let me go back to the problem so you can see how we get that height. So look at the height. It's, the full height is 15 feet, right? But we just want the height of the rectangle, of the triangle. So we have to take off the 9.5 to figure out just the part that goes from the top of the roof down to the point where we remove the base of it. So what is 15 minus this 9.5?
5.5.
Okay, so let's go back to the whiteboard. And so what did you say it was?
5.5.
5.5. Okay, so now we have all our dimensions. And so the area of, the volume of this triangular prism is the same as the rectangular prism, except for it's divided by 2. So it's base times height times length divided by 2. So that's 5.5 is the height. And then we have the 20, not 12, 20, which is the length, and the 12.
Why were you dividing it by 2?
Well, that's the equation for the triangle. Remember, triangles, the triangular prism is like half of the rectangular prism. So, you know, when you find the area of a triangle, you know what the area of the triangle is? 1/2 base times height.
Okay, yeah.
The area of a rectangle is base times height. So the area of a triangle is always half of the rectangle. Because if you think about a rectangle, if you cut it in half, you get 2 triangles. So there's 2 triangles in one rectangle. So the area of the rectangle is base times height, or length times width. And then the triangle is half of that. Okay?
Okay.
All right, so now, what is the volume of this rectangular prism? Tell me what you got.
660 volume, feet, inches cubed. Is it inches?
You got 660?
That's wrong.
Okay, so this volume, 660. So now if you combine the 2 together, you'll get the entire house, the entire volume. The part at the bottom plus the part at the top. So what's the 2 volumes together?
2,940.
2,940 cubic feet. Beatrice, does that make sense to you? Okay, so 2,940.
Yeah.
Let's go back to the problem. The problem that was asking us for the volume, and we choose 2,940, right? So we looked at this one house, we just divided into 2 separate regions. The top region was a triangular prism. The bottom region was a rectangular prism. We found the volume of those 2 separately, then we can just add them together. We had to do a conversion. We had to convert 4 yards into feet. And we also had to figure out the height of just the rectangular prism by taking the 15 feet and subtracting the 9.5 feet. And then we had to refer to our equations. The volume equals area of the base times height. So we needed to know the volume of a prism using this equation, B times H, big B, which is the area of the base times the height. So again, this is the reference sheet that's given to you on the test that you can refer back to. All right, so we got through number 17. Does anybody have any questions for me about anything that we've done or anything in general?
Oh, it's not a question, but I had to get go. I have a concert tonight. So.
Yeah, we're about to wrap up right now.